Welcome to today's session for the AICTE PRERANA scheme. So this scheme is mainly for the benefit of SC/ST students. So through this scheme, we are providing GATE classes. So that it will be useful for the SC/ST students' higher education. Okay. So so today's uh, class is about the subject of fluid mechanics. So myself, V. Santhosh, Assistant Professor, Chemical Engineering, Erode Chemical Engineering College. So the topic we are going to discuss today is fluid classification and their properties. So entire classification of fluids, so and the behavior of fluids and the properties of fluids. So based on the properties of fluids, we are going to discuss the previous year GATE problems. So, well, going for the classification of fluid flow. So the fluid flows are classified into various types. So depending upon the nature of the fluid, the flow of the fluid varies accordingly, right? So right from viscous flow and the inviscous flow, internal and external flow, compressible flow, incompressible flow, laminar flow and turbulent flow, steady flow and unsteady flow, natural flow and force of flow. So as well as depending upon the direction, it can be classified into uh, three types. So one is one-dimensional, two-dimensional, and three-dimensional flow. Right. So these are all the main classifications of fluid flow. We will see one by one. So what do you mean by viscous and inviscous flow? That is called as inviscid flow. So if the frictional effects become signification, so the fluid flow in which the frictional effects become signification, they are treated as. So when two fluid layers move relatively to each other, so the frictional force automatically develops between them. So right, so that relative movement of two fluids can be quantified using the fluid property viscosity. Right. So viscosity is a very important property which can able to predict the frictional force developed between the two fluid layers. Right. So the boundary layer flows are the famous example for this viscous flow. Right. So if you neglect the viscous terms in the governing equation, so the flow can be treated as inviscous flow. Right. So viscous and inviscous flow depends on the frictional effects of the fluid. Right. So whereas coming to the second type, so internal and external flow. So external flow means, so it is the flow of an unbounded fluid over a surface. Right. So for example, if the fluid is completely bounded by the surface of the fluid, so it is called as internal flow. So the famous example you can consider is flow over a plate is generally will be having the external kind of flow. So whereas a flow through a pipe or a flow through a duct will be having the internal flow, right, which is nothing but it is completely bounded by the surface. Whereas the external force is nothing but, so it is the flow of an unbounded fluid over a surface, right. So when if the duct is partially filled and if there is a free surface, so we will be calling that as open channel flow. So normally, if you take the internal flow, so the presence of viscosity will be very high. So it will be dominated by viscosity. So when we speak about the viscous effects, they will be limited to boundary layers. So in the solid surface for external flows, right? So coming to the compressible and incompressible flow. So the flow will be considered to be incompressible. So if the density remains almost constant throughout the particular system, so then we will call that flow as incompressible flow. So if there is a density variation more than 5%, in the sense, so that flow is treated as compressible flow, right? So this normally corresponds to a flow of Mach number of the range of Mach number is 0.3 at room temperature, right? So depending upon the density, we are classifying the flow of fluid as two types. One is compressible as well as incompressible. So while we speak about the laminar and the turbulent flow, here Reynolds number plays a very important role. It is a major characteristics in which we can divide this two types of flow. Right. So the highly ordered fluid motion characterized by smoother layers of the fluid is called as laminar flow. So which is nothing but, for example, for the laminar flow, the flow of highly viscous fluids at low velocities. Right. So they are called as laminar flow. The fluid motion that typically occurs at high velocities is characterized by the fluctuations that happened in the velocity. So they are called as turbulent flow. If you are having the high velocity profile of a fluid, which is characterized by fluctuation in velocity, so in that case, the flow of the fluid will be called as turbulent flow. Right. So in between laminar and turbulent flow, there is a flow uh, that the flow is called as transitional flow. The flow that alternates between laminar and turbulent flow is called as transitional flow. Right. So here we need to speak about the Reynolds number. So depending upon the Reynolds number, we can classify the flow, laminar or turbulent. If the Reynolds number is less than 2100, the flow is characterized as laminar flow. If it is greater than 2100, so that flow is termed as turbulent flow. Reynolds number is nothing but ratio of inertial force to the viscous force, right? So R is equal to dV rho by mu, right? So in that way, we can classify laminar and turbulent flow based on the nature of the Reynolds number, right? So while we speak about the steady and unsteady flow, so when there is no change in fluid property at the point with the time, so that flow is called as considered to be steady flow. There will not be any change in the fluid property, right? So, however, the fluid property at the point it can also vary with time. There is a possibility of variation of fluid property with time. So, which means there will be unsteady nature in the flow of the fluid. So, that is called as a transient flow. The unsteady flow of the fluid is also called as transient flow, right? So, this is denoted by capital T. So the term periodic here refers to the kind of unsteady flows in which the fluid flow oscillates about a steady mean. Okay, so depending upon the fluid property, variation with time with respect to time, we are classifying fluid into two types: one is steady flow and the unsteady flow. So next one is natural and forced flow. So in a forced flow, what happens means the fluid is forced to flow over a surface. Uh, Here they are needing an external agency by means of an external agent, for example, a pump or a fan or a compressor, right? So you are going to force the fluid to flow over a surface. So in such cases, the flow is called as forced flow. So whereas in natural flow, the density difference is the major driving factor for the fluid flow. Right. Also, buoyancy plays a very important role. For example, if you take a warmer fluid, so that will definitely rises in a container. If you keep a warm fluid in a container, the level of the warmer fluid will get raised. So that's due to the density difference, right? So depending upon the density difference, So natural flow is defined. Okay, right, right. So these are the major properties of classification of fluids that we have seen. So now we will discuss the various properties such as viscosity, density, shear stress, uh, uh, specific volume, specific weight. So there are a number of properties available for the fluid. So the important problems which are related to the uh, properties of fluid that has been asked in the previous year gates questions. So now we are going to discuss one by one. Okay. So take a look at the first problem. A plate which is having a 0.025 mm distance from a fixed plate, so moves at 60 centimeters per second and requires a force of 2 Newton per unit area. So that is 2 Newton per meter square to maintain the speed. So they are asking the viscosity between the plates. Determine the fluid viscosity between the plates. So they are given the distance between the two plates. Consider a fixed plate which is 0.025 mm apart from the other plate, right? So here dy is given as 0.025. So what is the force given? Force is given as 2 Newton per unit area. So that is 2 Newton per meter square. So for the maintenance of the speed, they are requiring this much amount of force. So you have to determine the fluid viscosity, right? So you know the shear stress. Shear stress is directly proportional to velocity gradient, right? So tau is equal to mu into du by dy. So that is a formula that should come to your mind whenever the viscosity has been asked. So from that shear stress equation, so you can easily determine the viscosity mu. Okay. So the what is given data here? So distance from the fixed plate is given as d 0.025 mm. So that is taken as dy. So next one is velocity of the upper plate is given, that is u is equal to 60 centimeters per second. So then force on the upper plate is given as 2 Newton per meter square. So F is equal to 2 Newton per meter square. So since force is given in meter, we can convert all the other parameters into meter. So if you convert 0.025 mm into meter, you have to multiply that by 10 to the power of minus 3. So likewise, you convert u is equal to 60 centimeters per second to meters per second, right? So you'll be getting 0.6 meters per second. So force is given as 2 Newton per meter square, right? So viscosity is nothing but it is mu. We need to determine mu. So we know that from the equation tau is equal to mu into du by dy. So du is given, that is change in velocity. So which is u minus 0. U is given for us. So 0.6 minus 0, you will be getting 0.60 meters per second. So next change in distance. So that is given as dy. Dy is equal to, we have already provided with the data 0.025 into 10 to the power of minus 3 meter. So now you calculate the tau. So tau is force per unit area. So that is given as 2 Newton per meter square, right? So you can substitute the values in that above equation. So tau is equal to mu into du by dy. So 2 is equal to mu into what is du? 0.6 divided by 0.025 into 10 to the power of minus 3, right? So you need to determine the fluid viscosity. So mu is equal to 2 into 0.025 into 10 to the power of minus 6 divided by 0.60. So if you simplify, you will be getting 8.33 into 10 to the power of minus 5 Newton second per meter square. Right. So convert that into poise. So 8.33 into 10 to the power of minus 5 into 10 poise. But now we will be getting 8.33 into 10 to the power of minus 4 poise. Right. So this is a very, very important problem where you will be given the change in distance and change in velocity along with the force. You have to calculate the fluid viscosity. Okay, for that you need to use the formula of tau is equal to mu into du by dy, right? So you can see the next problem. So determine the intensity of shear of an oil which is having the viscosity 1 poise. So the oil is used for lubricating the clearance between the shaft of diameter 10 centimeter and its journal bearing. So clearance is been given as 1.5 mm and the shaft rotating speed is given as 150 rpm. Right. So here you need to calculate the intensity of the shear. So write the given data first. So mu is given. So that is the viscosity. The previous problem you have been asked mu. Now the mu is directly given. So that is 1 poise, which is nothing but 1 by 10 Newton second per meter square. Diameter of the shaft is given. So that is d is equal to 10 centimeter, 0.1 meter. So what is the distance between shaft and journal bearing? So dy that is given as 10 centimeter. So oil is used for lubricating the clearance between a shaft of diameter 10 centimeter and its journal bearing. Clearance is given as 1.5 mm. So that is the distance between the shaft and uh, journal bearing. So dy is equal to 1.5 mm. So convert that into meter automatically. 1.5 into 10 to the power of minus 3. So you know the speed of the shaft. So that is capital N. So 150 rpm. So what is the formula used for calculating the tangential speed of the shaft? So u is equal to pi into d into n by 60. So you know the diameter, you know the speed. So directly you can substitute. So pi into 0.1 into 150 divided by 60. So you'll be getting the tangential speed of the shaft. So that is nothing but u. So u is equal to 0.785 meters per second. Right. So you know that from the Newton's law of viscosity, tau is equal to mu into du by dy. So where du is the change of velocity between shaft and bearing. Right. So you know, so u minus 0 is equal to u. So that is your du. So du is 0.785. So mu you know 1 by 10 into 0.785 divided by 1.5 into 10 to the power of minus 3. So you will be getting, if you simplify and solve, you will get around 52.33 Newton per meter square. So this is also a very important problem where you will be asking the shear intensity. In the previous problem, they have given the intensity and we have been asked to find out the viscosity. So here you need to find out the value of tau, right? So you can see the next problem. So two horizontal plates are placed 1.25 centimeter apart. The space between them being filled with the oil of viscosity 14 poises. So calculate the shear stress in the oil if the upper plate is moved with a velocity of 2.5 meters per second. So here also they have asked the shear stress. So that is tau. So see, distance is given. Distance between the plates, horizontal plates, is dy is equal to 1.25 centimeter. Viscosity mu has been given, so that is 14 poise. So 1 poise is equal to 1 by 10 Newton cent per meter square, that we know. So do the conversion, 14 by 10 Newton second per meter square. So you have the velocity. So the upper plate is moving at the velocity of 2.5 meters per second. So velocity of the upper plate is 2.5 meter per second. Right. So you have to calculate the shear stress. So tau is equal to mu into du by dy, where du is the change in velocity between the plates. Right. So that is u. U is given as 2.5 meters per second. So dy you know 0.0125 meter. So tau is equal to, you can directly substitute the value of mu is 14 pies. So 14 by 10, converting that into Newton centimeter per meter square into 2.5 by 0.125. So what you will get? You will get 280 Newton per meter square. Right. So unit is very, very important as far as the properties of fluids are concerned. So without unit, you will not be getting the correct answer. Right. So make sure that you are solving the problem along with the give proper unit. Okay. Right. So this is one important type of problem that has been asking continuously in the GATE exams. Okay. Right. So next, we are moving to the next problem. So the space between two square flat plates is filled with oil. Each side of the plate is 60 centimeter. Thickness of the oil film is 12.5 mm. So the upper plate, which moves at 2.5 meter per second, requires a force of 98.1 Newton to maintain the speed. So here they are asking two different parameters. So one is dynamic viscosity of the oil. You have to determine the dynamic viscosity of the oil in poise, and you need to determine the kinematic viscosity of the oil in Stokes. So the specific gravity of the oil is 0.95. Right. So what is given? So each side of the square plate is 60 centimeter. Right. So write that first. So from that side of the each side of the square plate, you calculate the area. So area is equal to 0.6 into 0.6. So you will be getting 0.36 meter square. So what is the thickness of the oil film? 12.5 mm. So that is dy. So dy is equal to 12.5 mm. So you convert that into meter. So 12.5 into 10 to the power of minus 3 meter. So what is the velocity of the upper plate? So velocity of the upper plate is u is equal to 2.5 meters per second. So that is given. Force is equal to 98.1 Newton. So they are asking dynamic viscosity as well as kinematic viscosity, that you need to uh, take a look at. Right. So change in velocity du is equal to 2.5 meter per second. Okay. So force is given as 98.1 Newton. So what is the shear stress? First you calculate the shear stress. So shear stress tau is equal to force by area. So we know the force 98.1 Newton. So each side of the square plate is 60 centimeter. So we know the area. So there is 0.6 into 0.6, 0.36 meter square. So first question is you need to determine the dynamic viscosity of the oil. Right. So for calculating the viscosity, you need to, depending upon the Newton's law of viscosity, you need to calculate the viscosity. So use the Newton's law of viscosity. So tau is equal to mu into du by dy. Right. So tau is 98.1 by 0.36. So we doesn't know the dynamic viscosity. So that is being asked. You give it as x, or you keep it as it's mu into du. What is du? Du is the thickness of the change in velocity between the plates. So 2.5 divided by dy. Dy is the area. Dy is the change in velocity. So that is the thickness of the oil film. So that is 12.5 into 10 to the power of minus 3. So you can calculate the dynamic viscosity from this. So mu is equal to 98.1 divided by 0.36 into 12.5 into 10 to the power of minus 3. You can bring that to the left hand side. So keep mu to the right hand side. So divided by 2.5. So you will be getting the answer in Newton second per meter square. So the obtained value is mu is equal to 1.3635 Newton square per meter square. So you know 1 Newton second per meter square is equal to 10 Pauls. So you convert that Newton second per meter square into Pauls. So 1.3635 into 10. So you will be getting 13.635 Pauls. So that is the required value for the dynamic viscosity, determined value. So next they have asked the kinematic viscosity of the oil. Right. So kinematic viscosity is equal to ratio of dynamic viscosity to the density of the oil. Right. So you know the kinematic viscosity is denoted by the symbol V. Right. So before proceeding to the substitution part, you need to calculate the density. Right. So they have given the specific gravity here. Specific gravity of the oil is given as 0.95. So whenever you have been provided with the specific gravity, and if you have been asked with the asked to find out the density, so the general formula is density is equal to specific gravity into density of water, that is 1000. So 0.95 into 1000. So you'll be getting 950 kg per meter cube. Okay. So that is the density of the oil, mass density of the oil. Right. So you know that kinetic viscosity is equal to dynamic viscosity divided by density. Right. So 1.3635 Newton centimeter per meter square divided by 950. So if you substitute, you will get 0.001435 meter square per second. So it is equal to, if you convert that into centimeter square, you need to divide that by 10 power 4. 1 centimeter square per second is equal to 1 stoke. Right. So you will be getting 14.35 stokes. Right. So whenever the kinetic viscosity has been asked, provided they have not given the density, only if the specific gravity has been provided, you need to find out the density using the formula density is equal to specific gravity into density of water. So you need to multiply that by 1000. So then only you can able to calculate the mass density. So then you can directly substitute in the formula. So kinetic viscosity is equal to dynamic viscosity by density. Okay. So this is also one major type of problem where they have been continuously asking in each year's gate chemical engineering question paper as far as fluid mechanics is concerned. Right. So be clear about that. So next, you can see find the kinematic viscosity of the oil having density 981 kg per meter cube. So the shear stress at a point in oil is 0.2452 Newton per meter square, and the velocity gradient has been given as 0.2 per second at that particular point. Right. So this is a very simple problem. As like the previous problem, we need to solve that. So mass density is given as rho is equal to 981 kg per meter cube. So shear stress is given as tau is equal to 0.2452 Newton per meter square. Okay. So du by dy is equal to 0.2 seconds. Right. So that is the velocity gradient that they have given directly. So velocity gradient, the previous problem, change in velocity and change in distance, they will be giving. So we need to substitute that in terms of velocity gradient. So here the directly they have given the velocity gradient. So velocity gradient du by dy is equal to 0.2 seconds. So tau is equal to mu into du by dy. So you know the value of tau 0.2452 Newton per meter square, which is equal to mu into what is the velocity gradient 0.2, right? So mu is equal to 0.2452 divided by 0.2. So you'll be getting 1.226 Newton second per meter square. That is the value of viscosity. So kinetic viscosity has been asked. So what is the formula of kinetic viscosity? Kinetic viscosity is equal to ratio of dynamic viscosity to the density of the particular component. Dynamic viscosity here oil. So dynamic viscosity, ratio of dynamic viscosity of the oil to the density of the oil. Right. So without knowing a dynamic viscosity, we cannot calculate the kinematic viscosity. So that you should note here. Okay. Even though dynamic viscosity has not been asked as a separate part, you need to calculate the dynamic viscosity in order to calculate kinematic viscosity. Right. So kinematic viscosity is equal to ratio of dynamic viscosity to the mass density of the oil. So you have already, we have calculated the dynamic viscosity value. So that is 1.226 divided by 981. So that is given as the mass density of the oil. Right. So 981 kg per meter cube. So it is equal to, if you simplify, you will be getting 0.125 into 10 to the power of minus 2 meters per second per meter square per second. Okay. Right. So if you know the conversion between Stoke, one Stoke is equal to 1 centimeter square per second, right? So 0.125 into 10 to the power of minus 2 into 10 power 4 centimeter square per second. So which is nothing but, so if we simplify, 0.125 into 10 power 2 centimeter square per second, right? So which is 12.5 centimeter squares per second. So which is nothing but 12.5 Stokes, right? So that is the answer for this problem, right? So you should know the kinematic viscosity formula clearly, which is nothing but kinematic viscosity is equal to ratio of dynamic viscosity to the density. Okay, right. So you can see the next problem. So determine the specific gravity of the fluid, which is having viscosity 0.05 poise and kinematic viscosity 0.035 Stokes. So here directly they have given the dynamic viscosity of the fluid and also kinetic viscosity of the fluid. What they are asking? They are asking specific gravity of the fluid. Okay. So how we can solve? The specific gravity is nothing but it is the density of the liquid divided by density of water. So this is a formula for estimating specific gravity of the liquid, right? So first you write the viscosity. Viscosity is equal to 0.05 poise. So you know 1 Newton centimeter per meter square is equal to 1 by 10 Newton centimeter per meter square is equal to 1 poise, right? So you convert that into Newton centimeter per meter square, 0.05 by 10 Newton centimeter per meter square. So what is the kinematic viscosity given here? Kinematic viscosity is equal to 0.035 Stokes. So 0.035 centimeter square per second. 1 centimeter square per second is equal to 1 Stoke. We know that. So you convert that into meter square. So you need to multiply that by 10 to the power of minus 4. So you'll be getting kinetic viscosity is equal to 0.035 into 10 to the power of minus 4 meter square per second. So what is the relationship of what is the formula for kinetic viscosity? So we can use the relation kinetic viscosity is equal to dynamic viscosity by density. So what is the kinetic viscosity value? 0.035 into 10 to the power of minus 4 is equal to 0.05 by 10 into 1 by rho. So we need to calculate the density first. So then only we can calculate the physical gravity, right? So Simplify by keeping all the terms in the left hand side and keep the rho in the right hand side. So rho is equal to 0.05 by 10 into 1 by 0.035 into 10 to the power of minus 4. Right. So you'll be getting 1428.5 kg per meter cube. Okay. Right. So now we can calculate the specific gravity of the liquid. So specific gravity of the liquid is equal to density of the liquid divided by density of the water. Okay. So what is the density of the liquid? So we have already calculated 1428.5. So density of water is 1000. We know that. So 1428.5 divided by 1000 is equal to 1.4285. 1.4285. Right. So this is a very important problem where you have been asking to find out the specific gravity of the fluid. Thereby, they are giving the viscosity of the fluid and kinematic viscosity directly. Right. So from that, you need to find out the density first. Then only we can find out the specific gravity of the liquid. Okay. So density of the liquid divided by density of water. So from that you can find out the specific gravity of the liquid. Right. So this is also one very important type of property estimation as far as fluid is concerned, fluid mechanics is concerned. Right. So we'll move on to the next problem. So here what they have asked, determine the viscosity of the liquid having kinematic viscosity 6 Stokes and specific gravity. So here they have given kinetic viscosity and specific gravity. So what they have been asked, what they have asked, viscosity. In the previous problem, what we have seen, so they have given the viscosity and kinematic viscosity directly. Dynamic viscosity and kinetic viscosity has been given, and they have asked the specific gravity. Here, specific gravity and kinetic viscosity is given. So we need to determine the viscosity. Same procedure, slightly we need to alter the formula. Right. So what is the kinetic viscosity? So kinetic viscosity is equal to 6 Stokes. So 1 centimeter square per second is equal to 1 Stoke. So automatically 6 into 10 to the power of minus 4 meter square per second. So we need to convert the 6 centimeter square per second into meter square per second. So specific gravity of the liquid is 1.9. Right. So now we need to calculate the density of the liquid based on the specific gravity of the liquid. So specific gravity of the liquid is equal to density of the liquid by density of the water. So what is the specific gravity of the liquid? They are given 1.9. So 1.9 is equal to density of the liquid divided by density of water. Density of water is 1000. Okay. So from that you can calculate the density of the liquid. So density of the liquid is equal to 1.9 into 1000. So you will be getting 1900 kg per meter cube. Right. So you have to calculate the dynamic viscosity. So you have been obtained. You have obtained the density of the liquid. So kinetic viscosity is directly given. So you need to use the formula of kinetic viscosity. Kinetic viscosity is equal to ratio of dynamic viscosity to the density of the liquid. So kinetic viscosity is 6 into 10 to the power of minus 4, which is equal to dynamic viscosity mu that we need to find out divided by density of the liquid is 1900. So mu is equal to 6 into 10 to the power of minus 4 into 1900. So it is nothing but 1.14 Newton second per meter square. right? So you need to convert that into pies. So you can multiply that by 10. So 1.14 into 10 is equal to 11.40 pies, right? So you can take a look at the next type of the property estimation of fluid. So here the velocity distribution for flow over a flat plate is given by u is equal to 3 by 4 y minus y square, in which u is the velocity in meter per second at a distance y meter above the plate. So you need to determine the shear stress at y is equal to 0.15 meter. So you have to take the dynamic viscosity of the fluid as 8.6 poise. So here they are asking the shear stress, right? So they are given an equation for the velocity distribution for a flow over a flat plate. Okay, so the given velocity equation is u is equal to 3 by 4 y minus y square. So what is from that you need to calculate the change in velocity with respect to change in distance. So du by dy, is equal to 3 by 4 minus y square. Differentiate, if you differentiate y square, you will be getting 2y. So 3 by 4 minus 2y, right? So we need to determine the shear stress at y is equal to 0.15 meter. So at y is equal to 0.15 meter, so what is du by dy? So du by dy is equal to 3 by 4 minus 2y. So instead of y, you need to substitute 0.15. So 3 by 4 minus 2 into 0.15, which is equal to 0.75 minus 0.30. So you will be getting 0.45. To substitute and simplify, you can get du by dy is equal to 0.45. Right. So next step, viscosity is given. Dynamic viscosity is given as 8.5 poise. So 1 poise is equal to 1 Newton cent per meter square. So 1 Newton cent per meter square is equal to 10 poise. So we know that. So automatically 8.5 by 10 Newton second per meter square. Right. So you can use the equation of Newton's law of viscosity. So tau is equal to mu into du by dy. Right. So what is mu is equal to 8.5 by 10 into du by dy we have calculated that is 0.45. So 8.5 by 10 into 0.45 Newton per meter square. So it is equal to 0.3825 Newton per meter square. Right. So if you have been given the velocity distribution for a flow over a flat plate and dynamic viscosity is given, you need to differentiate that particular equation and you need to find out the du by dy value. That is a simple concept behind this problem. Okay, right. So we can move to the next problem. So you can see. So if the velocity profile of a fluid over a plate is a parabolic with the vertex 20 centimeter from the plate, where the velocity is 120 centimeter per second, calculate the velocity gradients and shear stresses at a distance of 0, 10, and 20 centimeter from the plate if the viscosity of the fluid is 8.5 poise. So here they are asking the velocity gradient as well as the shear stress. So at three different distances. So the distance of 0, 0 centimeter, 10 centimeter, and 20 centimeter from the given plate. Right. So you can see the figure that has been given. So velocity profile of a fluid over a plate is parabolic in nature. So the vertex is given as 20 centimeter from the plate, from the base of the plate. Velocity is given as 120 centimeter per second. So that is your u. So you need to calculate the velocity gradients and shear stress. Viscosity of the fluid is given. So that is 8.5 poise. So write the from the given data, what is the distance of the vertex from the plate? So that is 20 centimeter. What is the velocity at the vertex? So the u is equal to 120 centimeter per second. So viscosity is equal to 8.5 pies. So we know that 10 pies is equal to 1 Newton second per meter square. So 8.5 by 10 Newton second per meter square, which is equal to 0.85. Okay, right. So what is the velocity profile in a parabolic equation? So, so the equation is of the nature u is equal to ay square plus by plus c, where a, b, and c are constants. So this value of constant, that a, b, c constant values has to be determined from the boundary conditions. So we are fixing three boundary conditions for this. So one is at y is equal to 0, u is equal to 0. When y is equal to 20 centimeter, u is equal to 120 centimeter per second. When y is at 20 centimeter, du by dy is 0. Right. So you take the first boundary condition A, that is substituting the first boundary condition in the parabolic equation. So u is equal to ay square plus by plus c. So at y is equal to 0, u is equal to 0. So u will be 0. So y is also 0. So a into 0 plus b into 0, automatically it will get 0. So c is equal to 0. So first constant has been identified. So now you apply the second boundary condition. So boundary condition 2 is at y is equal to 20 centimeter, u is equal to 120 centimeter per second. So 120, u is equal to 120. So we know the equation u is equal to ay square plus by plus c. So 120 is equal to a into y is 20. So 20 square plus b into 20 plus c is 0. Right. So if you substitute, what do you get? So a into 20 square, that is 400a plus 20b is equal to 120. Right. So now you go back to the third boundary condition. So this boundary condition on substitution, you have to substitute the boundary condition 3 in the parabolic equation. So E is equal to a square plus by plus c. Right. So you can differentiate that above equation, parabolic equation. So du by dy, differentiate the above equation with respect to y. So du by dy is equal to 2ay plus by. If you differentiate by, you will get b. So in the third term there is no y, so automatically it will get 0. So du by dy is equal to 2ay plus b. Right. So what is du by dy? So at y is equal to 20 centimeter, du by dy is equal to 0. So du by dy is equal to 0. So 0 is equal to 2 into what is a? A into a we don't know. Y is 20 plus b. So it is equal to 40a plus b. Right. So we need to solve the second boundary condition equation and third boundary condition equation. Equation arised due to the second and third boundary condition. So second equation is 400a plus 20b. Third equation is 40a plus b. So if you simplify and solve, so you can get the value of b. So b is equal to minus 40a. So you can substitute the value of b in equation 2, and then you can find out the value of constant a. So 120 is equal to 400a plus 20b. So b is equal to minus 40a. Right. So 120 is equal to 400a plus 20 into minus 40a. So if you substitute, what will you getting? So if you substitute 20 into minus 40, you will be getting minus 800. So 120 is equal to 400a minus 800a, which is equal to minus 400a. So a is equal to 120 divided by minus 400. So you'll be getting minus 0.3. So now you have estimated the values of constants a, b, and c. Right. So Now you can substitute the value of A. A is equal to minus 0.3. So we know that B is equal to minus 40 A. So that is the equation we have already obtained. So B is equal to minus 40 into minus 0.3. So which is equal to minus into minus will get cancelled plus. So you will get 12. That is the value of B. So you know C is equal to 0, A is equal to minus 0.3 and B is equal to 12. So we know the equation. So U is equal to ay square plus 12, sorry, by plus c. Okay, so a value is minus 0.3. So u is equal to minus 0.3 y square plus b is 12 plus c is 0. Okay, so now you know the velocity gradient. Velocity gradient we need to determine. So velocity gradient at three different values. One is at a distance of 0, one is at a distance of 10 centimeter, and another one is at a distance of 20 centimeter. So du by dy is equal to, you can differentiate the equation. So with respect to y, so du by dy is equal to 0.3 y square. So y square, if you differentiate, you will get 2y. So 2 in minus 0.3 into 2y plus 12y. If you differentiate 12y, you will get 12 with respect to y, right? So you'll be getting minus 0.6y plus 12. So first substitute the first condition. So at y is equal to 0 centimeter. So du by dy at y is equal to 0. So instead of y, you need to substitute 0. So minus 0.3 into 2 into 0 to get 0. So minus 0.6 y plus 12. So minus 0.6 into 0 plus 12. So you will be getting 12 per second. Right. So if you substitute the second condition at y is equal to 10 centimeter, du by dy y is equal to 10. So instead of y, you need to substitute the value of 10. So minus 0.6y plus 12. Minus 0.6 into 10 plus 12. So you will be getting minus 6 plus 12. That is 6 per second. So at y is equal to 20 centimeter. So du by dy is equal to y is equal to 20. So which is equal to minus 0.6 into 20 plus 12. So minus 12 plus 12 is equal to 0. So minus 12 plus 12 is equal to 0. So that is the condition for third distance. So now we have calculated three velocity gradients. So one is at a distance of 0 centimeter, one is at a distance of 10 centimeter, and another one is at a distance of 20 centimeter. Right. So now they have asked shear stress also. So we know the formula for shear stress. Shear stress is equal to tau is equal to mu into du by dy. Okay. Right. So shear stress at 3 points we need to determine. So shear stress at y is equal to 0, shear stress at y is equal to 10 centimeter, and shear stress at y is equal to 20 centimeter. Right. So tau is equal to mu into du by dy at y is equal to 0. So you need to substitute y is equal to 0. So 0.85 into 12. So that is a 10.2 Newton per meter square. So we know the value of viscosity, that is 0.85. Okay. Right. So that is you are substituting here 0.85 into du by dy at y is equal to 0. So you know du by dy also. Now the value of du by dy at y is equal to 0, what is that? 12. Right. So you need to directly substitute that. So 0.85 into 12, that is 10.2 Newton per meter square. So shear stress at y is equal to 10 centimeter. So tau is equal to mu into du by dy at y is equal to 10. So that is 0.85 into, we know the value of du by dy at y is equal to 10, that is 6. So 5.1 Newton per meter square. So shear stress at y is equal to 20 centimeter. So tau is equal to mu into du by dy at y is equal to 20. So that is 0.85 into 0. So which is 0, right? So this is also a very important type of problem where they will be asking velocity gradients along with the shear stress. Okay, right. So far in this class, so we have discussed the classification of fluids. What are the different types of fluids available and how they have been classified, and also depending upon the various properties, the estimation of property of the fluid, the problems we have seen. Right. Thank you.